Hello everyone. In this video we will learn how to read electrical diagrams. I assume that viewers have some fundamental or even advanced knowledge of electrical field as well as basic understanding of various electrical equipments and devices. By end of this video, you will be able to read and understand the control and power or wiring diagram of electrical system. This is the first video where we will explore the power and control diagram of 415 volt induction motor, which is relatively simple to understand and consists of two pages. In the next video session, we will cover the 6.6 kV induction motor diagram, which is more complex of 6 pages. The wiring diagram could be 1 page to 100 pages depending on the system requirement. The symbols and standards varies country to country. The layouts are based on the company's requirement. Mostly this diagram can be created using software like Visio or electrical CAD softwares. So let us start with the 415 volt induction motor diagram. You can see here two pages of diagram containing numbers, letters and symbol. For example, most of you will feel familiar with the terms like 214 volt, 415 volt 3-phase bus, ammeter, start stop buttons, etc. However, you will be also noticing other numbers and abbreviations like F1, L2 and so on. If you are unfamiliar with the electrical symbols, I recommend referring to the IC or ANSI standard symbols. You can easily find the IC 60617 standard by searching it on Google. To make it easier, I have attached the screenshot of ANSI and IC symbols with the descriptions which I found on the Banner Engineering website. You might also have noticed some specific numbers on the diagram. These numbers are defined by the IEEE standard C37.2 published in 2008. A quick Google search with this standard will show you a table of these numbers. You don't need to memorize all of these number right now. As you work with the diagram, you will start remembering them with the practice. For now, let us focus on memorizing the first number 49, which represents the thermal overload relay for the machines or transformer. Another thing, you have to observe the top bar with some digits and the total number of pages. Since this is a scanned copy, the page number was missing, which I have added manually for better understanding. The top horizontal bar having some numbers, these are called the column number. You can see 11 to 18 and on second page is 21 to 24. When I say find the contactor in this diagram, it might be difficult for you to understand, and also there are so many contactors are located in the diagram. Even if I say find the contactor K1, still it is difficult to locate it on the diagram. But if I say find contactor K1 which is in column 11, so it become easy to identify the location or the device which is located in the diagram. Similarly, if I say find contactor K2-6, and it could be difficult. But when I say find contactor K2-6 in column 21, since it is located on page 2, it's easy to find, right? The second thing that is clear, which is the column number and the page number. Now let's come back to the main focus of the diagram, which is 415 volt induction motor. On page 1 you can see the motor and its connection, and on page 2 you can see the indication diagram, which is very simple to understand. These are the contactors. This is the symbol of control cables, then resistor, and finally the neon bulb. We will see how these indications are displayed during the start and stop operation of the motor. Let's come back to the first page again. When we talk about induction motor, the protection scheme depends on the motor rating and the application. Typically, large motors are protected by the comprehensive induction motor protection relays. However, the small motor up to 100 kilowatts are protected by only thermal overload relay or HRC. I mean the high rupture capacity fuses against the short circuit or overloading. In this diagram, the motor is connected to 415 volt 3-phase switch gear, and it is expected to operate in a moist environment. To prevent the moisture built up in the motor, the stator winding I mean in the stator winding, because it's normally hygroscopic in the nature. So to avoid the moisture built up inside the motor, the the space heater with 213-volt AC single phase supply is necessary to be keep on while motor is in off condition, to keep the winding warm. The heater should be turned on when motor is not running to maintain the required temperature, it means. However, when the motor is operating, the heat is generated by its own losses, which is sufficient to eliminate the moisture and making the heater unnecessary on during the motor operation. So it means when your motor is in running condition, no need to keep the space heater on. You can turn off the space heater. Normally, it is turned off automatically by some interconnection or interlocking mechanisms. The induction motor is connected to 415-volt three-phase AC supply through a switch fuse unit, you can see here, and the contactor, the contacts of K2 contactor. Here you can see the current transformer is linked to the motor to measure the current using ammeter and provide the input to the thermal overload relay which protect the motor. The contactor K2-123 is in open condition standstill situation, you can see here, and the control circuit is responsible for managing the motor's operation when it is powered by a 415 volt. Actually, this control circuit is getting power supply from this transformer, which step down the 415 volt to 110 volt. You can see it is located in between the 13 column number 13 and 14. To control the motor, I mean the on off operation or trip function, you can do it either by locally or remotely. When the power supply is connected to the motor's control circuit, here you can see in diagram. The local refers to the motor's physical installation site, while the remote refers to the location where 415-volt switchgear is installed, means the control room. Normally, the switchgear, or you can say the control room, is located at some distance from the motor, which is inside the plant. For example, the steel rolling mill, or let's say some cold storage farm, where the operators are not normally available beside the motor because it's in like a hot or cold environment. Operator is available in the control room, which is at some distance for the safety of the operator, which is in the control room. An emergency stop button is installed in the central control room as well as the local location for the safety purpose. When the motor is turned off, the interlocking circuit automatically switches the heater on to prevent the moisture buildup. So here in this case, we assume that the motor is in some, let's say, some plant where the moisture is present due to might be cold storage, or might be some, let's say, some water is sprayed around the motor. Okay, so a local remote, here you can see a local or remote selector switch which allows the control of the motor either from the local site or from the remote switchgear location. This switch is positioned at the motor's local installation site. When the motor is undergoing maintenance or repair works, the selector switch is set to the local position so that it ensures that no one from the control room can operate the motor from the remote location. Now, to start the motor locally, the local or remote selector switch is placed in the local position. For example, let's say right now we are placing the selector switch. I hope you know how selector switch looks like. So here this is the selector switch where we are keeping it on the local position. Then the local start push button is pressed. So this is the push button. It means when you press the button, the continuity of circuit is there, and when you release, it will um, it will break the path of current. Okay. So when the local start button is pressed, coil of contactor K1, which is in column 14 or 15, is energized and causing its contacts to change the status. I hope all of you know basic functioning of contactor, which are normally used for the operating high voltage circuit using PLC, or some manual control using low voltage circuit for the safe operation. For example, here you can see the contactor of coil which is connected with the 24-volt supply, and upon energization of the coil, the HV terminal closes and it's turn on the motor. So basically, it's kind of some isolation or for the safe operation of the high voltage circuits. So when the local start button is pressed, the coil of contactor K1, which is in column 14 or 15, is energized and causing its contacts to change the status. So you can see clearly the path of control circuit is completed. If you trace from the secondary side of transformer to fuse F4, then 49-1, which is a thermal overload relay contactor, then contact selector switch S2, and then push button, then remote stop, local stop, emergency stop, and then K1 coil of contactor. Here at K1 you can see A dash B, which is written, and below also you can see the symbol with A and B with four contactors that are presented in the different column numbers, and also with NO NC state. Also, I assume that you know NO is normally open and NC stand for normally close, which is indicated in diagram. For example 2 normally close NC contact of K1, which is located in column 11, which are 34 and 56, sorry, which are 3 4 5 6 will open, and it will cutting off the power supply to the space heater. Okay, so initially, I mean, at the very first operation is the it will break out, I mean, it will off the space or space heater. Simultaneously, one normally open ano contact of contactor K1, which is like K1-3, which is located in column number 18, will close and energizing the coil of contactor K2. As a result, the contactor K2's associated contacts will also change their status, which are which you can see at the bottom of uh, page 1, which is which are 1 to 14 contacts. Okay, 1 2 3 4 up to 14. Also in column 18 you can see K3-1, which was already closed since it's NC contact, it's normally closed contact, and then the path is completed to energize the coil of contactor K2. Okay, now the next is three normally open contacts of contactor K2 in column 12, you can see will close. So when 1 2 3 4 5 6 get closed, the path of motor circuit will be completed from the three-phase supply to switch fuse unit to K2-1 2 3, and finally the motor which will start the motor, I mean it will turn on the motor. Okay, another ano contact of K2, which is K2-4, located in column 17, will also close to provide the hold on path for the circuit for contactor K2. Okay, ensuring it's remain energized. So when you press the push button and release, technically motor should also get stopped because it's a push button. So after releasing the button, it should get stopped, but it will not halt because there is another path called hold on path provided by K2-4 in column 17, and motor will remain energized. You can trace the path here. Okay. Additionally, NO contact of contactor K1 in column 21 will close, which you can see on page 2. It will turn on the neon bulb to indicate that the motor is in running condition. You can use different color of neon bulb like red, yellow, or green to indicate in its start, stop, or whatever preference you have. Okay. Simultaneously, the normally close contact NC contact in column 22 will also open, and it will turn off the neon bulb which indicate the motor is off. These indications are useful for the operator which are sitting in the control room. Now the motor can be stopped by pressing either local or remote off push button. In event of emergency, the motor can also shut down manually by pressing the emergency stop button. When you press emergency stop button, which is also a kind of push button, causes K1 to de-energize and reverse the operation, which will happen with all the contactor and motor will get stopped. Okay. Similarly, the motor can be started remotely by setting the local remote selector switch to the remote position and pressing the remote start push button. The motor can be controlled manually or automatically from the remote location using a remote or a remote auto manual selector switch. Okay, when the motor when the remote start button is pressed, the contactor K1 is energized, and the same process for starting the motor locally is repeated and turn on the motor. Most motor, in most of the cases, the motors in power plants are operated sequentially. So, as mentioned earlier, like motor can only start if permissible signals or interlock mechanisms are provided. When in automatic mode, the motor will start automatically and provide the permissive and interlock permit if available. Uh, in case if motor becomes overloaded, the overload relay will detect it, which is 49 number we already talked, this is a thermal overload relay. So 49 dash 1 relay contact in the column 11 will change its status. This will energize contactor K3, and the NC contact of contactor K3, which is 34 located in column 18, will open and de-energize the coil of contactor K2. As a result, there is a 3 NO contact in series with the motor will open, causing the motor to trip. Okay. At the same time, the NO contact of contactor K3 in column 22 will close, and the signaling trip indication you can see on the second page. The trip indication alerts the operator that motor has tripped due to overload, and this ensures that motor is not restarted until the cause of overload has been addressed. Another thing you can notice in this diagram is the spare contactor, which you can use for additional connection. For example, let's say hooter, okay, which is also kind of indication for the operator. So these are some spare contactor which you can use for in future if you have some other mechanisms or some other logic things you want to develop. The last thing is the future permissive interlock, which are useful for sequencing operation. For example, some operation that must be done before starting of the motor, so you can use this contactor for that purpose. So this is all about this 415 volt induction motor power and control diagram. I hope it is clear to you. What you can do is you can take the printout of this uh, 2 pages. I will upload it on the link provided in the video, and you can download and you can take the printout, and you can repeat this video by keeping printout in front of you, so it will be easy for you to understand. And from this we can go in the advanced level in the next video, which I am preparing right now. I'll go for the 6.6 kV induction motor, which is a bit complex diagram. So if you have any particular questions, you can comment down below, and uh, and you can subscribe the video for uh, you can subscribe the channel for the latest video in the electrical field. Thank you everyone.